Hello everyone, my name is Manav Jain and today I will be presenting on full stack development and backend architecture. In this presentation I will be making you understand how modern web application work, which actually starts from front end as we all know, and all the way to the backend systems, which includes database and deployment, all those stuffs. And first of all, let's understand, as we already have a unit in the Chitkara collaboration degree of SIT 331, and in the last semester we have SIT 313, which was front end, and in that we have already developed some front end application, Deacon web page application as well in the part of that course. And similarly, in the backend development, which is in this current semester of SIT, where we have SIT 331, we have to develop and create a full stack development with the secure backend services course. So we implement some of the databases as well. For example, we have a major focus on PostgreSQL for our database structure. So in this throughout the video, we are gonna understand how actually the backend is doing the stuff all throughout our full stack development thing. And let's move forward to see how and understand first of all what actually is a full stack. So full stack development means working across all layers. When I say all layers, it actually represents the web application. We usually have web application which includes front end as a part, back end as another part. Front end is what where the user usually interacts, it's just the user part, and the back end which handles the logic and processing. And the third thing, integrating the both, which we can see is database, where actually our data is being stored. And the front end is typically built using technologies like HTML, CSS, JavaScript, or frameworks like React, which we implemented in last semester for our front end course. And in the backend, which is built using frameworks such as ASP.NET Core, which we are currently using in this semester. And database store application data efficiently, we are using PostgreSQL as in for example. A full stack developer understands how all these layers communicate and works together. So it is very important to as a full stack developer to understand how these web application actually work and integrate all these three systems. Moving forward, as every web application nowadays follow a request response cycle, such that for example when a user performs an action like clicking and is an example clicking an button, the front end sends an HTTP request to the backend, and the backend processes that request, applies business logics for example, and then interacts with the database if requires. For example, when I say I have wanted to delete a particular thing, we have a delete button for example, right? Then we click a delete button, it sends a request to backend checks if that the particular user has a particular authentication or not. If that's valid condition, then it interacts with the database, otherwise it directly denies it. Or and the front end as well, we have a verification to check if that a particular user has a valid role to access that deletion feature. And similar feature we have already seen in our unit SIT 202, where we go into detailed request, where in the network communication, for example how actually the requests go on, for example from acknowledgement and back to acknowledgement, receiver response, all those stuffs we are not going into detail. So finally, when a response is sent back, usually in the JSON format from, and it is displayed to the user, not in the JSON format obviously, so cause of course user cannot understand it. So understanding make it more in an interactive way, user can understand, cause even though user cannot understand the code even, yeah, so to make it simple, understanding this flow is quite essential for debugging and building an efficiency system as well. Moving forward, we have architecture, as I mentioned, to build an application as well. So mostly modern application follow three tier architecture, otherwise it can go up to n layer architecture to make it more secure and advanced, even an efficient system. And first layer is the presentation layer, which handles the user interface, all the browser HTML, CSS. The business logic is the second layer, which processes all the rules and decision which to access not, and the data layer which manages the database operations, and this is the third layer where all the databases repository are to be included. So this separation makes application easier to maintain, test and scale. So this is just a basic layering of the our application, which includes only three layer. Otherwise, for example, we have a separating layer as well. For say, you can see we have a four layer architecture as well, where we have several advantages over the previous layer, like a less layer with the tier architecture. First, changes in one layer do break others as well, like all these four layer work independently. Second, the team can work independently on different layers as well. And the third, it improves the testing because business logic can be tested separately as well. For example, over here you can see the client actually is going to send a request. Controller acts as a traffic controller to check all the requests and respond, handle all the requests and response, for example. And service layer checks matches what actually that the response was, goes to based on the business logic or model. This is a kind of cycle. Over here you can see goes to database interaction, CRUD operation to be occur or not, all those occur before the before directly acting upon the database, and we are just interacting with the repository and the model first of all, and then model and repository, they both interact with the database, not directly user can interact with the database. Otherwise it will make a lot of confusion and even the conflicts can occur. So to avoid that, we have made so that the user cannot interact with the database directly. Now we have a backend framework. As I mentioned, you are using ASP.NET Core Web API, you can say, which is a fast scalable framework, and it supports routing which maps the URL to the its particular function. Controller which handle incoming requests. It also follows the REST principle using HTTP methods like get, post, put and delete. These are all the requests I have some mentioned. Even the patches there, these are just the major one which I have mentioned, as we have already learned about get to receive that request, or for example to say put to update and post, some of those are mentioned. And additionally with the middleware processes as well to request for logging and authentication and even the error handling. These are just for the middleware function or the pipeline, for example to say. Moving forward, what actually we a lot of have a talk about what about the controller. So let's understand what actually the controller is. Controller acts just as an entry point for API, as we already see a traffic policeman standing to control everything, as the name suggests, to control. So this is an entry point for API request as between the client. If the client firstly interacts with the controller, of course they should not remain thin. First of all, they only handle request and response. While coming to the DTO, data transfer object are used to transfer data between client and server, which you can see even in the image as well. So they helping hiding sensitive information data and shape response and validate the incoming data or incoming inputs as well. So this makes our API more secure and maintainable, because DTO helps to just make an abstract thing. They cannot show like a password to a user, so they just hide it, those such information. And similar thing, controller, they just do the part of request and response thing, none other things. So this was just to make our application secure. Now moving forward, we have a lot of heard about dependency injection throughout this semester and throughout this unit as well, which is an important part when we talk about the full stack development. Dependency injection is a design pattern where dependencies are provided, as the name suggests, which externally we provide those injections. As for example, as the name already suggests, we are injecting some dependency externally instead of being created inside a class. So this leads to loose coupling. There are some disadvantages, of course, because we are actually bit modifying the actual existing class. So there are, for example, as I mentioned, loose coupling, which means components are independent of each other. It improves scalability because services can be easily added, and most importantly it makes task testing easier as well by allowing mock services as well. Because as I mentioned about loose coupling, it is actually an advantage in the form, because everything is now as an independent thing. They are not independent, they are not dependent actually, because even the when we talk about loose coupling, each team can handle the services based on their requirement, based on the task, which is actually an advantage for an application in the system. And you can see, and even in the example I have mentioned, and we have actually used this example for us to say. Now moving forward, we have discussed dependency injection. Now we have which is the recent, and to make our application secure, we use JWT, JSON Web Tokens. So this is the stateless authentication, which doesn't store obviously, because these things are being used by our modern application. You have recently heard about these JSON web based token. These are for the authentication purposes. For example, when a user logs in, the server generates a particular kind of token, and this token is sent with every request to verify the identity. Even for example, when I compare with the real life example, when you log in the bank application, they generate a token which is validated for a certain period. After that token expires, the user validation is gets off. User needs to log in again. Even the same thing you can see in the D2L as well, to check it off whether the but when we log in the D2L and gets the minimize that D2L and open another application of that D2L for a long period, for say 2 to 3 hours. After 2 to 3 hours, when we go back to detail, you see that it checks whether the user is actually there or no. You have to click yes or no, or even the session out in error message, or even the pop-up message is seen on our website, so you need to sign in again. So this is similar. We use JSON web tokens. JSON JWT is a stateless, meaning no session is stored on the server. Even there are a lot of logins, so we cannot handle or store it for a longer period. So that's why it's stateless beneficial. It contains where when we talk about the JSON structure, it contains header, payload, and signature. Payload as a data, for if data here taken as the ID, role, and expiry time or date, and header algorithm of what token type it is, and signature prevents tampering. Signature to particularly identify that token, to validate that token. So these are to just to ensure the security. Now moving forward, what actually the database basics are, or when we talk about, because backend is all about database, right? A database is used to store and organize the data, as the name suggests, database. We have a lot of heard about this Netflix using various databases, or in the geographical phase. For example, Netflix is considered to be the most prominent one in the field of backend. So taking as one example, because it has distributed system where its server are distributed throughout the world in the geography, so we can interact with our nearest server based on the server which is close to one, and interact and see movies or even the shorts and series based on whatsoever it was. So backend, for the backend, Netflix is the one for the prominent application. And for example, the Facebook or Instagram are also there, but Instagram is in prominent in the way, or in the field of front end. But better when we talk about backend, I am talking about Netflix, which is the prominent. So there are two types, relational and non-relational databases. So we are actually using relational to be fair. Relational databases are data is stored in the form of tables with rows and columns. And for those relational databases, we use SQL queries like select, insert, update, and delete, and they are used to interact with the data. And for example, this is a table which I have created. This is just a user table with basic fields, basic columns like ID, name, email, and row and role. Well, when I all as I mentioned, there are two types of database. This is the relational one which I mentioned. Non-relational one, this actually don't use tables format. They are actually used for when we talk about the post we made, or in the Facebook application or in the Instagram, to just store those. They are not actually. So relational database are more of the formal way, while the non-relational are non-formal way. Moving forward, when we talk about there are obviously some of the deployment and cloud applications which I mentioned, because we are actually now moving forward after database. After creating application, we deploy our application. As once those application is ready, tested, it needs to be deployed, as I mentioned. So for those, the platforms of, for example, as Azure and AWS host application. Even if you remember, we used Netlify as an deployment application in our previous semester for front end deployment, which cannot be obviously used for backend. But for the backend, there is a certain application to mention about is Railway, where you can deploy that particular application even in the front end as well as the backend. Even you have heard about the Docker itself, which we have used in our first year for to integrate with our embedded system project. But if you have not used, well, I will create the project idea about how to use Docker in the further video. But to mention what is the Docker is used to containerize application which ensure consistency across the environment. And even we are being used Docker in our professional development unit as well. If you not use, no worries, I will be creating the tutorial for that as well. And fourth is the CI/CD, the pipeline, which is a continuous integration and continuous deployment, because in the automation of the testing and deployment, because everything is to be tested in this, it is creating a kind of cycle where testing deployment goes for long, which makes the process faster and more reliable actually using this CI/CD pipeline. So to conclude, full stack development, which includes what it actually includes was the front end and back end, and along with it, it actually also includes the databases, security, and deployment. It is not actually about the front end and back end. It is about making our application more secure. So understanding how these components work together is quite essential for building a scalable, efficient application. So mastering this architecture makes us a complete software engineer, as there are a lot of jobs available above the full stack developer. So it is quite important to understand all these technologies which we use, for example PHP, MySQL, all those we have already used, even the languages we are using. So these are just basic topics which I told you about, and the concepts to understand about full stack development, creating a secure backend architecture. And stay tuned for my further tutorial animation video as well. I hope if you like this video, make sure to like it, subscribe it my channel. And this was all about today. Thank you so much for watching me.